All right, in this problem, we're going to compute the number of functions with domain B6 and target B6. Now, to show you how we can rephrase this in the form that we've seen in previous examples for this lesson, let's say that A is the set B6. And now, okay, so B6, right? B6, right? This is bit strings of length 6. So the 0, 0, 0, 0, 0, 0 is in there. Let's see, that's 6, right? The next thing in there, if we're going to write them in, I guess that would be lexicographical order, I believe. It would be like that, right? And so on and so on and so on. Okay, so let's give each of these a name. We'll call this first thing, say you write them in some particular order. The first thing we'll call x1, the next thing we'll call x2, and so on, right? So we can write B6 as x1, x2, x3, on up to the last x, right, which would be 1, 1, 1, 1, 1, 1, right? Which one is that? What's that? That's going to be the last one in B6 if we write them in this order, going from smallest to largest, right? If we were to think of those as numbers or something. This would be, so remember we found already that there's 2 to the 6th elements in B6, so this would be x sub 2 to the 6th, right? Whatever 2 to the 6th is. All right, so this is going to be x 2 to the 6th. We can play that exact same game with b. Say b is b6, y1, y2, y3, all the way up to y2 to the 6th. Whatever 2 to the 6th happens to be. I can figure it out. Let's see, what is 2 to the 5th is 32. I guess that's 64, right? So x sub 64 or something, right? 2 to the 6th, 2 to the 5th is 32, 64, yeah. But let's not do that. Let's just write it as 2 to the 6th. Okay, now remember, we can represent these functions as sequences. We can represent we can represent each of the functions with domain A and target B as a sequence, right? A sequence of length 2 to the 6th. So let's see, you've got 1, 2, 3, dot, dot, dot. So I'm putting a little dot, dot, dot in there because I'm not going to, so I'm not going to write out all 64 of those. So we have 2 to the 6 positions. And remember with functions, not necessarily a one-to-one functions, right? It's okay to have repeated elements, right? So it's not permutations, it's just a sequence. But in any case, we have each of these as a choice for each one of these 2 to the 6 positions. So we have 2 to the 6 choices, 2 to the 6 choices, 2 to the 6, 2 to the 6. And so the answer, right, the number of these functions is, let's see, you have 2 to the 6 to the, it's 2 to the 6 times 2 to the 6 times 2 to the 6 times 2 to the 6. So the answer is 2 to the 6th to the 2 to the 6th power.